So today we will start with that yesterday's concept, right? So that is nothing but the campus design consideration. Okay, so in last session we already done with this first infrastructure device characteristics. These are the some network application characteristics and their consideration. In that also we have discussed four applications, that is peer-to-peer applications, client and local server applications, client and server farm applications, and the last one is the client to enterprise edge server, right? So in all these four network application, we have also seen there is some different examples, right? So after that we already discussed about this environmental characteristics as well, right? So if in network is in between the intra building or in between the inter building, or if you are using some distance remote building, you are using this kind of the networks, right? Then how these particular constraints will be taking place in your networking designing, right? So today in our lecture we will see what I mean by this transmission, how this transmission media related consideration will be take place, right? So what are the different transmission media you are going to use in your infrastructure network, right? And how it will be we will see with the help of one example, right, how it matters, right? Then we will see the infrastructure device characteristics and consideration, convergence times and cost and all that things we will see, right? After that we will see the types of the switching, multi-layer switching and Cisco express forwarding, right? What I mean by that, right? So we already seen in a couple of before lectures, that is what I mean by switching, multi-layer and layer 2 switching, right? So in this also we will see what I mean by multi-layer switching, and with respect to the Cisco devices, how this Cisco express forwarding can be used, right? Then we will see the QoS consideration in LAN switches and load sharing in between the types of the switches, that is layer 2 and the layer 3 switches, right? So we will start our lecture from this particular transmission media consideration, right? So we will see yes, the transmission media consideration if we talking about, right? So you already know that in whatever the infrastructure if you are having, right, the cabling part will be a crucial one, right? So because it is nothing but the long time or a long term investment, right? And it is very costly also, right? And and it is a very we can what can it will be also depending upon your the organizational, what is organizational available budget, right? For the networking part, right? And how how much contribution from that you are going to use for your medium, right, or the transmission medium, that is also important one, right? So here if you see in transmission media, right, so we have a certain transmission media. For example, if you see the copper cable is there, right? So we can also call it as a twisted pair cables, right? Then the optical fiber cable is there, right? So we can call it called as the fiber cable. And then the next one is your wireless cable, right? So wireless in terms of what? So satellite, then microwave, right? All these are nothing but your the wireless medium also we can see, right? So if you see the this particular copper, right? So twisted pair cables, nothing but the copper cable, right? So it will be isolated wires, right, that will be wrapped together in a plastic cable. If you obviously you are observed that particular cable, right? So this particular cable is less expensive if you compare with the fiber optics and all, right? But it will be, and also it will be widely used, right, over the for interconnection in between the different workstations, servers, right? If you are using in NICs also for network connector, if you are using, right? And what is the characteristics of it? If you see, it will be obviously it will be depending upon the what kind of the material you are using for preparing that particular twisted pair cable, right? and obviously it's having there a certain categories, right? For example, the cat 5, cat 6 cable, right? And which will be also depending upon the its speed also, right? The 100 mbps, right? 1000 or gigabit ethernet, right? So it depending upon the speed and all the cable types will be there, right? And that also you need to must know. So for which type of the speed, which type of the copper cable you are going to use, right? Twisted pair you are going to use, that also you must know, right? Then if you consider the fiber, optical fiber, right? So optical fiber, here there are two types, right? The fiber and the SM fiber, right? So this fiber is nothing but your the multi-mode fiber, we can call it as, and SM fiber is nothing but your single mode fiber, we can call it as, right? Because this multi-mode fiber, which are very light in weight, right? And it will be having some less diameter, right? For example, if you see here, though, up to only 2 kilometer distance can it will be used, right? And if it is in greater, and then we can use this particular SM cable, right? So all these things you must know, right? And after that, if you see this wireless, right? So wireless also we can be used with the help of some access point devices, right? So these access points already you have seen in our college campus also, right? So in each and every wing, each and every floor, there is an access point which will be we are using for our wireless part, right? And you can see our college campus is also your Wi-Fi enabled campus, right? So because of that, we are using this wireless transmission media also, right? So if you see in this particular transmission media components, right, comparisons, if you see with respect to this copper twisted pair, or SM fiber, right, multi-mode, and the single mode fiber, and then the wireless one, right? So there are some different parameters on which we have comparing on these transmission media, right? For example, if you see, the first parameter is nothing but the distance, or we can call it as in range, right? So distance in between the you can consider networking devices, right? For example, workstation are there, servers, different printers, or different IP phones if you are taking, right? Then distance between these networking devices, or you can consider a different networking nodes, you can consider, right? So how much is the distance in between all these things, right? And depending upon the distance, you can use this fast ethernet or the gigabit ethernet, or you are to use any fiber optic fiber cable or not, right? So depending upon distance you can decide, right? For example, if you see in this first distance parameter, right, for copper twisted pair, it is we can use up to the 100 meters, right? For fiber, multi-mode fiber, we can use up to 2 kilometers, or you can fast ethernet cable we can use. If up to 550 meter, then we can use the gigabit ethernet. Up to 300 meter, then we can use 10 gigabit ethernet, right? So depending upon the distance, you can check which cable is useful for your organization, right? For example, for SM fiber up to 10 kilometer, we can use fast ethernet, SM single mode fiber up to 5 kilometer, gigabit ethernet up of SM fiber, right? Likewise you need to decide. Then for wireless up to 500 meter, then we can use 1 mbps speed wireless access point we can use, right? So depending upon the distance, you can decide so which transmission media it will be used for your organization, right? So you can decide easily with the help of this particular chart, right? Then if you see the second parameter, that is nothing but the bandwidth, right? So bandwidth of that particular segment, or we can call it as the connection speed, right? The connection speed between all the nodes, right? So whatever it may be, it may be inside nodes or the outside node of the building, right? So depending upon the connection speed, you can decide, right? So which cable you are going to use, right? For example, if you see here in a copper twisted pair, right? So up to 10 gigabits gbps if you are using, then you can use this particular twisted pair, right? If to up to 10 gbps, you can use fiber, right? So up to 54 mbps you can use in wireless also, right? So depending upon that also you can decide, right? Then the third parameter we are doing comparison with the help of this price, right? So if you see this particular price is not only about the transmission media, right? It will be also depending upon your the installation costs, right? So whatever the transmission media you are using, right, so for installation of that transmission media, obviously it will be a costlier one, right? And that also you need to consider here, right? So with respect to that, if you're using this copper twisted pair, then it will be inexpensive. There is no such a more cost of that particular copper twisted pair, right? And if you compare with this fiber and fiber, right, so it will be moderate to use for fiber, it will be moderate to use for wireless, right? Why? Because for wireless you need to just required an access point and the PoE, right? So with the help of that you can use this particular wireless channel, right? And for SM fiber it will be because of you are using only a SM single mode fiber, so it will be moderate to expensive, can be in sometimes, right? So this is nothing but the price parameter. And then we will see the deployment area, right? So deployment area is nothing but where you are actually going to deploy your transmission media, right? So that you need to check upon, right? For example, if you're using wiring for wiring closet, right, for internode or inter-building connections, right, then you want to also see about the whether there is any magnetic or electrical disturbance or interference is there or not, where you are going to deploy that particular cable, because that disturbances may cause that particular data transfer in between the connections, right? So for that purpose also you are going to check this particular deployment area, right? So for copper twisted cable, if you are seeing here, the wiring closest must be there. Then for fiber internode or interbuilding you can use in SM fiber also the same, and for wireless also the same, right? So depending upon that also you can select a transmission media that which you wanted to use, right? So that also you can check. Then we will move towards the next, that is nothing but the infrastructure device characteristics and the consideration, right? So if you see here in this infrastructure device characteristics, right, so here we have if you are designing any type of the switch, right, so whatever switch you are going to use, right, and the features for that particular network where you are going to deploy that particular switch, right? So there are some factors you need to keep in mind. For example, the factors where I have listed here, the first one, the infrastructure service capabilities, right? So for example, whatever the network services, right, you are using for your organization, right? So you need to also think upon the what are the qualities or capabilities of that particular networking services are there. For example, if the service is giving you the IP multicasting packet, if your service is giving you the proper QoS, that quality of service parameters and so on, right? So that you need to be kept in mind, or that you must be identify, right, the capabilities of your infrastructure layer services, right? Then the second one is the size of the network segment, right? The size of the network segment means how your network is going to be segmented, and how different end devices are to be connected with that particular network, right? So because it will be obviously it will be based upon your the network characteristics and your traffic characteristics, right? So how many end devices are connected with your your network, and your network is segmented into how many part, right? So that is also depend and it will be depending upon your infrastructure devices, right? Then the third one, if you see the convergence time, so this is nothing but the time which will be we can consider as, for example, if any services is down, right, or if any your network is down, you are seeing this particular network outage thing and all, right? You heard about that network outage, right? So that will be we are considering as a convergence time, right? So how much time that particular network is down, or that particular network outage will be there, so that particular time is nothing but your convergence time, we can call it as, right? And the fourth one is your nothing but your cost. So this particular cost is nothing but we can call it as a budget, right? So budget for any kind of the network infrastructure you can consider as a cost, right? So for example, I want to give any example. Then for example, the multi-layer switches, which will be more expensive, right, than the layer 2 switches, right? So now depending upon your organizational requirement, you can think which one is suitable for your organization, right? So that will be we can consider in terms of your cost, right? So this is also very much important, right? Then we will see the yes, the multi-layer switching and the Cisco Express forwarding, right? So this particular point, that is multi-layer switching and all, we already covered in our previous session, that is in when we are studying this structuring and modularizing the network, right? So in that also, right, because whatever your multi-layer switching, we can call it as switch, which we are having the capability to use the information which we can be used for other different protocol layers, right? That is nothing but your the multi-layer switching, right? So we can also call it as an layer 3 switching, okay, in a for a multi-layer switching, okay. So with respect to Cisco, if I'm talking about, right, so with respect to Cisco, we have two different ways, right, for the switching. So first one is nothing but the multi-layer switching, and the second way what we have, that is nothing but the Cisco Express forwarding, right? So in Cisco devices, mainly we have this particular two types of the switching and forwarding is there, right? So we will see what happen in the multi-layer switching, right? So so this particular multi-layer switching, now the name gives you as an answer, right? That is nothing but which will allow switching to at a different protocol layers, right? So multi-layer switching, we can use a different protocols, right? Different protocols layer we can do the switching, right? For example, in switching, you can perform at layer 2, layer 3, or sometimes in a layer 4 as well, right? So that can be you can used, okay. Then there are some three main components of this particular multi-layer switching. If you see, the first one is your MLS root processor, right? So this particular root processor is nothing but the router, right? So that can be perform the traditional function of the routing in between the different network, or you can call it as the different subnets, right? Because for example, routing, what routing can be done, it will be transfer your packet from one route to another route, right? So in between the subnets, or in between the different networks, you can route, you can use this particular root processor, right, for multi-layer switching, right? So and the second component, what we are MLS switching engine, right? So it will be switch, right? So we can have some of the packet switching functionality, whatever this particular multi-layer switching having, right? So to reduce some kind of the offload of that particular root processor, right? So this particular switching engine can be used, right? So this particular switching engine can be responsible for to offload some of the packet switching functionality from this particular root processor, right? And this last one is multi-layer switching protocol, right? So it will be we can use to communication in between these particular two components, right? The first one is the MLS root processor and the switching engine, right? So to take place the communication in between these two protocols, two components, we are using this multi-layer switching protocols, right? Because this allows the communication between two devices, right? For any different LANs, then we can have these particular root processors, right? And then if you are talking about this particular Cisco Express forwarding, right? So the main purpose of this particular Cisco Express forwarding is what, to speed up the data routing and forwarding, right, into the network, okay. So to speed up all the data routing information, to speed up the any data forwarding process from any kind of the network, then this Cisco Express forwarding we can use, right? So these are the two different approaches we are using in under this particular Cisco Express forwarding. The first one is your forwarding information base, right? So it will be general we are using for the layer 3 information, right? And for the second one, that is adjacency table, we can use for the layer 2 information, right? So for example, if you are doing multi-layer switching, or you are doing layer 3 switching, right, then this management this forwarding information base FIB we are using for Cisco's express forwarding, and right, and if we are doing this layer 2 switching, then we are using this particular adjacency table, right, for the layer 2 information part. Okay, so these things you must know. Okay, then we have this particular IP multicast, right? So what do you mean by the IP multicast and all, we will see. Okay, for example, if you see any kind of the IP network, right, which will be not efficient for sending same data to many locations, right? If you having some data, right, and you wanted to pass it to the several users, right, and at that time that particular IP network will not be useful, right? And why I'm telling it is not be useful, right? For example, if you if I want to give one example, right? For example, the one organizational CEO is having some conference, right, and he wanted to send some data to all the employees, or he wanted to send some video to all the employees to watch, right? Then that particular same data can be streamed, or the same data can be replicated to each of the employees, right? But obviously it will be consume the more resources for that from that particular network, right? It can be consume more bandwidth from that particular network, right? So this particular IP multicast technology, right, which we are using, that can be used to send a data to a group of the people or group of the destination in a most efficient way we can use, right? So in that we can use this particular the protocols, right? So the first protocol we can use is the IGMP, and the second one is this CGMP protocol we can use, right? So if you see in this particular diagram, right, so IGMP we can use in specifically in between the host and their particular router, right? So if you are seeing this particular example, right, so from host, for example, this particular server to this particular root, we are using this particular IGMP protocol, right? That is nothing but the internet group management protocol we are using, right? And from this particular root to this particular switches, we are using this CGMP protocols, right? That is nothing but your CGMP protocol is nothing but your Cisco group management protocol, right? So here if you see in this particular IGMP, right, so here this particular host we can register with this particular router, right, for to send a specific message to this particular multicast group, right? And if this particular router only knows that what you need to send to this particular multicast groups, right? So in this particular network now, if you see these particular routers which are connected to this particular layer 2 switches, right, and this IGMP network is in the nothing but in a layer 3 protocols, right? So in these layer 2 switches which we are not participating in this multicasting, right, multicasting of that particular IGMP, right? Therefore it will be not part of this particular multicasting group, right? So this particular layer 2 switches can be flood multicast frames to all these particular ports, right? So that is nothing but the aim of this particular switches, right, to transfer each and every packet, right, to broadcast each and every frames to all the ports, right? So that means the multicast traffic which are received by this particular switch now, it will be send out all the ports, right? Okay, and that's why this particular CGMP is comes under the picture, right? Because the switch is the specific groups which want to receive that particular multicast packet, right? So but other groups also receiving that particular packet, right? That we don't want. Okay, so we want to restrict somewhere, right? and for that purpose this particular Cisco group management protocol, that CGMP, we are used. Okay, in between these particular switches and the routers, right? And with the help of that particular CGMP, we are able to send only the multicast package to those IP address that we want to send. Okay, so that's why this particular CGMP, Cisco group management protocol, we are enabling on this particular layer 2 switches, right? So this is all about your IP multicasting. So how IP multicasting can be done with the help of this particular IGMP at host to router part, and for the CGMP for from the router to switch part. By using all these things, we are able to send IP multicasting packets, right? So now the third one is your protocol independent multicast routing protocol, right? So we can call it as an PIM, right? So protocol independent multicast routing protocol, right? So it will be used by the routers, right? Which will be useful for the routers for forwarding multicasting packets, right? So if you see the unicast, it is nothing but the unicast routing protocol. Okay, and for example, if you see EIGRP, then OSPF, these are the routing protocols, right? We will see all these routing protocols in a deep in a next coming lecture, coming chapters, right? So then you will understood that what are the different routing protocols and their purpose or their functionalities are, right? So we are using this particular PIM, that protocol independent multicasting model, can use routing table of routers, right, to showcase their unicast routing protocol, right? So it in that particular it will be calculate its multicast routing, and then it will be use that particular or that forward that particular unicast packet from that particular routers, right? So it will be again use all these things dynamically, right? So it's having some types of the distribution trees. If you see here, the source tree and the shared tree, right? So this particular source tree is nothing but is created for each source sending of each multicast group, right? And the source tree has its root at the source, and has branches throughout the network to the receiver, right? And the shared tree is nothing but a single tree which should be shared in between all the sources from each multicasting group, right? So which we can call it as an RP, right? So whatever the data you are sending from this particular single tree, right? So it will be shared in between all the sources or the leaves of that particular tree, right? And which having some one common root, right? Which we can call it as an RP, right? So that also you need to keep in mind. And then also it having this particular multicasting routing protocol, it works on the two modes, right? The sparse mode and the dense mode, right? So the sparse mode is nothing but it will be used a pull model, right, to send the multicast traffic, right? For example, if you are seeing that pull and push part in a git, right? So like that here also it will be uses this pull model to send the multicasting package, and the push model it will be uses for your to flood the multicasting traffic, right? Then that we can call it as a dense mode, right? So that is also you need to keep in mind, the sparse mode and the dense mode. And source tree and the shared tree will be uses for sending traffic from your multicasting routing, right? Then we will see this particular QoS consideration in LAN switches, right? The QoS in LAN switches, if you see here, right? So when we are configuring any QoS parameters, right, or any QoS features to traffic to some classify any of the network traffic, right? So or to prioritize on any of the importance thing, right? For example, congestion management, or example some policing and shaping techniques to improve the network performance, right? Then these particular QoS parameters or QoS performance will be used for is more effective, right? So here if you see in the diagram also, this data link layer switches are commonly used in a building access layer. If you see here, right, so this classification of marking, congestion management, all these things which are done in this particular distribution multi-layer switching, right? So and because of we need to provide this QoS parameter, so that's why we are giving here. If you see the multi link redundancy is also there, right, to avail all the packets which are transferred from the sender, it must be received at the end of the receiver, right? So that's why this particularly QoS can be maintained in that particular case, right? So that can be, we can use in these particular LAN switches also. Okay, so data at obviously the data link layer, this particular switches are be working as at access layer, right? So you can remember whenever I am talking about this access layer, so that is nothing but your the labs. So what where we have 301, 302, 303, the switches in that particular labs are nothing but the access layer switches, right? And which obviously the connection will be taking from the lab number 312, that is your distribution layer switches, right? So in that particular LAN switches we need to configure, if we need to configure this particular QoS, then link redundancies, then path redundancies, route redundancies, all should be maintained, right? So it will be managed to it will be help to manage this particular conjunction management, then policies and configuration and all these parts, right? So that is also one point. Then we will see about this particular load sharing in between these two switches, like layer 2 and the layer 3 switches, right? So if you see in layer 2 switches, right, if you compare all these two load sharing of this particular layer 2 and layer 3, right? So as you know, this particular layer 2 switches will be only aware of only the MAC addresses, right? Therefore they cannot perform an intelligent load sharing if you compare with the layer 3, right? Because if you see in the layer 3, it will be capable of switches can perform all these load sharing based on the IP addresses and based on their destination source IP and all that things, right? So therefore the advantage of this particular layer 3 load sharing is what the links which are used by this load 3 layer 3, right? So it will be more proportionately than the layer 2 load sharing, right? Because it will be based on the obviously your VLANs, right? Virtual LAN it will be uses. And if you see in layer 2, the one uplink could be configured to carry all the VLANs, right, with odd numbers, where the other uplink would be configured to carry the VLANs with the even numbers. So there are two uplinks here we are using for layer 2 load sharing. One is for the odd numbers and one is for the even numbers, right? And if in with respect to layer 3, if you are seeing in the traffic in one VLAN can be very heavy, then while the traffic in another VLAN is very slow. In this case, per VLAN load sharing by even and odd VLANs is not appropriate, right? For example, if you consider in layer 3 the layer 2 case, right? So here I am using odd numbers, here I am using even numbers, right? And if the traffic in between the one for example in odd numbers is very low, and for example in even numbers it will be very heavy, right? So these particular odd and even VLANs will not be appropriate, right? Why? Because there is a dynamic nature of the organization application, right? Some of the critical applications will be required more network part, right? So that's why this particular load sharing will not be appropriate, right? So that's why this layer 3 will be more appropriate one, because it will be allows and dynamic updation of that particular link utilization, right? And it will be obviously depending upon your the router protocol design. So which routing protocol you are using for your own network, that will be depending upon the routing protocols part, right? And because of this dynamic adaptation of link utilization, this layer 3 will be very much important while the load sharing part, right? Because as you know, in layer 2 load sharing, if one is having heavy traffic and one is having a very low traffic, in that case this particular odd and even will be failed, right, or is not appropriate one, right? So that's why layer 3 load sharing we can use, and it will be preferable, right? So yes, so that's it for today. So we have seen today the transmission media consideration, then copper cable, wireless cable, and then fiber optic, SM and MM, we have already seen. Then infrastructure device characteristics we have seen. Then multi-layer switching and Cisco Express forwarding, their components we have seen, right? Then QS, how the QS will be important in the LAN switches, right? The quality of service. Then the load sharing in between the layer 2 and layer 3 switches, and which layer switches load sharing which will be very much important or advantage over the layer 2 load sharing, that also we have seen. Okay, so this is all about today. So we have a online test here, so ma'am will post a link in a chat box, so go with the test. Okay, thank you for joining. We will stop today.